Okay, I think we're recording. No pressure whatsoever. All right, so obviously you're here to talk about TypeScript. Hopefully, is anyone here not familiar with JavaScript at all, by the way, just to get that out of the way? If you're not, you can probably still follow along, but the assumption is that you've had at least some exposure to JavaScript, but this is an intro-level talk to TypeScript. All of the positive social media can go to @Jeremy Likness. That's my Twitter. I also do accept direct messages, even if I haven't followed you back yet. You can direct message me and say, why haven't you followed me back yet? And I will respond. So if you have any questions, feel free to reach out to me after that. So I'm a cloud developer advocate at Microsoft, and I get a lot of questions about that. I'm going to talk about that in a minute, and I promise I won't spend too much time on it. I've been developing professionally, actually, since probably about 2 years before JavaScript was invented as a language. So I'm not sure if I should be proud of that or not, but that's where we're at. I do write books, articles online, and print. I probably won't be writing any print books anytime soon because they take too long to go to market, and by the time you publish them, that technology's moved on. I do speak quite a bit. I love to talk. Just ask my wife or my daughter. And for almost 5 years now, I've been following a 100% plant-based diet. I'm a runner, a hiker. I enjoy doing those things. And I even have a blog. It's amazing. So for cloud developer advocacy, and I do want to say that I did code this in JavaScript myself, so I will take credit for the animation. This is Bit the Raccoon, and that is a mascot for cloud developer advocates for any company. And raccoon was picked because we sort of get into everything. It's kind of, the sky's the limit. Now, unlike traditional evangelism, where we would report up through sales or marketing, this is actually an engineering team at Microsoft focused on reaching developers. And there's really three key things we look at. One is community, and that's coming out to user groups, going out to conferences, connecting online through Twitter, LinkedIn, etc. We focus on content, so that's generating blogs, videos, and especially a ton of documentation. And then we have a real connection with engineering. So I work with the product teams at Microsoft. So if you are not familiar with Azure, our cloud-based offering, or if you are familiar and have pain points that you want someone to vent for, again, I accept direct messages. I'll be happy to work with you. And I can definitely take those back to the team at headquarters because we're very serious about making the products good for developers. And that's about all I'm going to say about Microsoft because this talk is focused on JavaScript. So I like to warm up a little bit with a little bit of background on why I think JavaScript is so interesting. And if you have a chance and you haven't seen it, there's a great talk that's actually called What? And if you Google What, you'll find it. He's a lot funnier than I am in the talk, but it's fun to watch. But I kind of borrowed the concept, so I wanted to give credit. But if you see what's on the top there, we've got this empty array and a +1. And then we kind of don't have an answer, and then I've got a button, and if you can't read the button, it just says what. So does anyone want to venture a guess what an empty array plus the number 1 evaluates to?
Not a number.
Not a number? Anyone else?
Object.
Object. So we got 2 answers. What? It's actually 1. Okay, so an empty array -1 would be, anyone brave enough? -1. What? Yes, it's -1. You are correct. What about an empty array plus an empty array?
0.
I heard 0, integer. I think I heard ice cream somewhere, message string. It is actually an empty string. That's why you see nothing there, because it's empty. What about an array minus an array? That is, of course, 0. Makes perfect sense, right? I mean, if you add them, you get an empty string. If you subtract them, you get 0. What about an array plus an empty object?
Empty object.
Empty object?
Bracket, object, object, bracket.
Bracket, object, object, bracket. What? It's an object. We're not quite sure what it is, but it is an object. So logically, if you take an array and you subtract an empty object, you're going to get what? Not a number. Makes perfect sense, right? So an empty object plus an empty object is obviously not a number. An empty object minus an empty object is also obviously, so someone thinks I'm trying to trick them, but it's still not a number. Therefore, an empty object minus 1 is not a number. 0, I heard. That's actually obviously negative 1. So would the type of an array minus an array equal the type of an empty object minus an empty object? I'm testing your memory because we've evaluated both of these.
42.
What? This is true. Both of them are not a number.
That's why I Google stuff.
All right, so I want you to, exactly. That's my favorite pair programming pal, by the way. Sometimes I'll start with Bing, but I end up on Google. But so I want you to wrap your head around this really quickly so it'll be easier to understand. There is a method in JavaScript called is not a number. And if it's true, it means what you pass to it is not a number. An exclamation mark is a not operator, so I'm saying not is not a number. Bear with me. What I'm doing here, and there's no foolery going on, I'm saying is it a number? Not is not a number, logically is a number. So I ask you the question, is 1 a number? Yes. And if we evaluate it, we get true. So far, so good. Is the letter A a number? No, of course not. So we get false. Is not a number a number?
No.
I've heard yes and no. We're just going to go ahead and go with it. Not a number is not a number. So that evaluates the false. Is not a number a number? No, false. So therefore, obviously, the type of not a number is number. What? Okay, these are the things we get to deal with as JavaScript developers. 1 times foo. Everyone's lost confidence completely at this point. It's not a number. 1 plus foo. He got it. It's 1 foo. Come on now. Obviously 1 foo. What is the complement of math.pi? So I'm getting into bitwise operators now, so.
Not
All
a
right,
number.
I'm just going to evaluate it. It's negative 4, obviously. What if I take the complement of not a number? Obviously it's 3. Come on, people. Bear with me. So the reason it happens is it's a bitwise operator. It reverses the sign, but the bitwise operators always drop the decimal portion. So when you're negative, dropping the decimal portion takes you over to the negative 4 side. When you're positive, it drops you down to 3. Type of an object is? Object. All right, we've got some confidence back. Type of null, triple equal type of empty object. A lot of false. Are you programming with JavaScript? Because this is absolutely true. Null is a special value that is a type of object. So, knowing that, type of undefined is? Oh, very confident about that one, undefined. Very good. 1 plus 1, triple equal 1 plus 1. Yes, 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 true, of course. Empty object plus array, triple equal empty object plus array. False, because not a number is not equal to not a number. Go figure. Does anyone know what this fun little statement will do? Jeremy's talk is cool, 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 cool. 4 times. So think of it as listing the array out with commas, but what you join it with takes place of the commas. So therefore, an array join of cool plus 1 is going to be, if we put the word tall in front of it, we could end the day with a tall, cool one, cool one, cool. Okay, great. So now this is string interpolation. So if you haven't dealt with the backtick, what it does is it allows you to evaluate expressions within the string. So we've got the literal BA. The $sign says evaluate what's inside the braces. We're doing an array2 join cool minus 1, and then we have an A at the end. Can anyone guess what this will evaluate to? All right, that's great. I wish I had something to give you besides just pointing and smiling, but that is absolutely banana. And then finally, I'm going to leave you with this exciting one. So there's actually a site that's not safe for work that does this, but then there's one that is. If you look for, I think hieroglypher is what it's called, but JavaScript, the way it evaluates expressions, you can actually write code with nothing but these symbols, plus and not and braces. So does anyone know what this would evaluate to? I mean, it's right there, it's obvious, it's definitely the number 3, right? So anyway, hopefully you understand why we might think that, JavaScript could use some help. Let me zoom in on this picture for you here. Oh, that's right, we are in adaptive view window, so we're not going to do that, but that's okay. I'll actually walk you through this if you can't read it. So 1995, which was exactly 1 year after I started my professional programming career, someone spent 10 days and wrote the initial JavaScript language. Pretty cool feat. It was initially written as glue to take, get this, Java. Anyone know Java? Few hands. So Java at the time was gaining popularity as running in the browser as Java applets. And so this was written as a way to allow the Java applet to interface with the document object model or the browser that it was in. So it's called Mocha. It was released as LiveScript. And then one of the most confusing name changes in the history of programming, the name was changed to JavaScript. And to this day, non-technical people go, oh, you work on that Java? And people get confused between JavaScript and Java, which are obviously not the same thing whatsoever. Through 97 and 99, we actually had standards quickly, and I think a lot of people miss the fact that JavaScript has been standardized for a long time. What wasn't standardized was the document object model, the way the browser exposed its APIs. Every browser wanted to do it differently. So if you can't see this, this is a raccoon, and it's on fire, and it's like, this is fine. And those were kind of our years of writing everything we wrote for the web 3 or 4 times, because we had to use different code for every single browser. And there was a lot of code that was cut and pasted. I think someone came up with this way of swapping out images dynamically, and anyone who coded in the late 90s has that code in their code base somewhere. But 2005 was a huge turning point because jQuery came out. And what jQuery did is it normalized the DOM. It let us focus on a single way to turn something on or off or change an attribute. And jQuery itself worried about browser A, browser B, browser C. So it took away that headache of having to worry about the different browsers. So that was helpful. 2009, someone had the brilliant idea of running JavaScript on the server. And then in 2012, TypeScript came out. So 5 years ago, it was actually late in 2012, so it was just about 5 years ago. What was interesting about TypeScript when it was released is to that point, there had been attempts like CoffeeScript to tame JavaScript and provide type and structure and formatting. But the challenge with those is they were completely their own languages. So you had to learn a whole new set of syntax. What TypeScript did is it said, we're going to embrace JavaScript, and everything that is valid JavaScript is going to be valid TypeScript. And instead, we're going to superset the language. So we'll add features on top of it, and then compile it back down to JavaScript, but the syntax and conventions should be familiar. We're not going to make you learn a whole new set of stuff, and I'll show you kind of what that looks like. And then in 2015, ECMAScript came out, and there's a lot of talk, will TypeScript get needed, and I'm going to address that in a second. So with Harmony /ES6 /ECMAScript 2015, and then with tools like Babel, and I'm sticking behind Babel. I've heard it as Babel. I'm sticking behind Babel. I've had this confirmed in numerous places. But the whole idea is you've got this new way of writing JavaScript. And if you want to just target modern browsers, you can go ahead and do that. And then you have things like classes that are first-class citizens. You don't have to use immediately invoke function expressions and these interesting patterns to make something behave like a class. You have different scoping options, etc. So those are all part of 2015, and Babel came out and said, I'll let you write 2015 and I'll compile it back down to the older browsers so you can use the new stuff. But what it was lacking, and what I'm going to show you, is interfaces, what we call dynamic module affinity. So the ability to include pieces of code and defer until compile time if you're going to use require or common or AMD or some other type of loading mechanism. External library definitions and generics are huge. I'm going to show you what generics look like and what they are in the scope of TypeScript. So my exposure to TypeScript initially was working on a team that was about 26 developers on a project that I was on for 2 years. It turned out to be a 5-year project, building this massive system. We're actually taking about 30 different disconnected systems for a Fortune 500 company and trying to unify them into one process flow with a web front end. So we had built this project 6 months of JavaScript, and for some strange reason, the customer called us in, and I don't know if this has happened with anyone else here, but they said, can you get it done faster? We want more quicker. Has that happened to anyone? I don't know. So we sat and we thought about it because, at some point you can't just throw new people at the equation, right? You can have brilliant developers, but the communication overhead becomes so high it's just not getting done faster. So we looked at some options and we decided to try out TypeScript. The reason why we like TypeScript is we wouldn't have to port the entire code base. The existing JavaScript could stay, and then we just compile new modules with TypeScript. And if we needed to pull the cord and say we give up, then we could just take what was compiled out of TypeScript, check that in as a JavaScript module, and we're done. So it felt like low risk to us. I'm going to talk about what the impact on the project was in a second, but I want to tell you what we've learned from our retrospective. These are sort of the things when we talked about it at the end, why was it successful, that we found. So the first was discovery, and that just means the intent of APIs is clear. I know JavaScript purists love that it's a dynamic language and that's a power of the language, and that's absolutely true. But at the end of the day, if you have an algorithm that is processing 2 numbers, you want to know that that algorithm expects 2 numbers. Just because you can pass a string to it doesn't mean you should, right? So this makes it very explicit so that you can discover what's needed. It's almost a sort of documentation. In fact, as I show you examples, you're going to see the intelligence that's in the code editor that's inherent to the language because it can use these different types of hints and types and interfaces to build out documentation on the fly. Version safety. Again, I take credit. I did the dynamic image swapping myself. I did not use the code from the 90s, though. This is more modern. But when targeting older browsers, the nice thing about the commitment of TypeScript is they're committed to following the spec. So if there's a 2018 spec for JavaScript, TypeScript will adopt those features and just compile directly to them when that becomes mainstream. So in other words, you're always current with the latest version of TypeScript because it's always using that syntax. So you're going to see things like spread operator and things like lexical scoping that I'm going to explain later that are the exact same as ECMAScript 2015 because of that parity behind the specification. Nope, wrong way. Development time security. This is perhaps one of the biggest advantages, is catching errors, because you saw that I can pass in foo to what I expect to have a number, and I may not catch that in an extremely large application with tens of thousands of lines of code until it's too late in the process and it's going to incur an expensive overhead. Scope safety. This is how many people sometimes get confused who write a lot of JavaScript on what is this? Like, you feel like if that song, What Is It, actually said, what is this, that would be your life, right? Programming in JavaScript. So TypeScript takes care of this, and I'll show you how. Team scale. I've worked with large teams after the initial project I talked about, and they always seem to be able to scale better because of these other reasons that we're talking about. I can put someone over here to work on one module, someone over there to work on another module, but they're informed based on type definition and interfaces and contracts. And so that makes it easier to scale the team. And then increased velocity. So this is what our team found. From the moment we had a user story that said something needed to get done, to the moment it was signed off by QA in production, we saw a 4 times increase in velocity for delivery of code, which the customer was a little bit happy about that. That kind of hit the mark. And I mean, come on, everyone knows Angular, right? The Angular team uses it. What more do you need than that? Forget all my other bullets. Know any Angular developers? Any Angular developers bitter that they switched to TypeScript?
At the beginning.
At the beginning. Awesome. Love to hear your story. Here, let me get a mic. No, we'll connect afterwards. All right, so enough of me blabbing. Let's go into a demo and actually look at some of this in action. So I'm going to flip over. Who here is familiar with Visual Studio Code? Few hands. So when I would ask this last year, it was a lot fewer hands. It's my IDE of choice because literally it'll run on any machine, Linux, Mac, whatnot. In fact, I even had a talk where a laptop I had at the time crashed, and I am not a Mac user. I have nothing against the Mac. I'm just used to PCs. That's what I do most of the time. And the only laptop someone had to lend me was a Mac laptop. Fortunately, I had my presentation on GitHub, and I used Visual Studio Code, and I was still able to give the presentation. So that kind of proved the cross-platformness, if that's a word, of it, right? Okay, let's set something up here. I'm just going to bounce into a terminal. And in this window, we don't have to worry too much about the nuances of how Node's running in the background. But I'm just setting up auto compile. So this is going to just blow up. And yeah, let's actually change into the samples directory. That'll work better. And then we'll run this. So this is just going to watch what I do in TypeScript, and if I make a change and save it, it'll recompile it to JavaScript automatically for me. And then I'm going to pop into another terminal here, and this will let us run some of these samples that I'm going to show you. So let me zoom in one more. And just, can anyone not see what I'm showing for code? Everyone good? All right. So this is something that you should be familiar with in JavaScript, var x equals 2. All I've done is added what's called a type annotation. I'm just telling TypeScript that I'm expecting x to be a number. And then I'm logging it with this string interpolation. So this is supported in modern browsers, but not in older browsers. But I'm still using that format, which is pure JavaScript, and I'll show that in a little bit. But because I've typed x to a number, if I try to assign it a string, I get this little squiggly. And if I can hold my hand still enough, hello is not assignable to type number. So it's already doing type checking for me and keeping me honest with what my intent is. Here I set a string, and this is going to be exciting, I know, but we're going to see another red squiggly. I can't assign a numeric to a string, and I'm sure you can guess where this is going, right, with the check property. Checked equals string true. It's not going to like it because it is a Boolean. And so that's what the expectation is. Here I'm actually typing a list. So I'm telling it this array, I expect everything in the array to be numeric. So pushing a 4 is fine. But if I try to push a string, again I get an error. It's not assignable. We're expecting numbers. There's some more advanced ways to do this that I'll show you in a second. It also supports enumerations, so I can enumerate bored, interested, neutral. I'm not going to make everyone answer this question, but let's just assume the interest level right now is still interested. So that's why I'm assigning to this variable. And what's interesting about the way it implements enumerations is you can actually get the string value of the enumeration. So it's stored internally as a number, but the way it creates the object, it'll actually give you the string value, and I'll show you that. We can put type annotation on functions. So if I say the function is going to return nothing, it better return nothing. This is saying I can't return 1 because I said I'd return nothing. But the key at the end of the day that I like to tell people is that the power of JavaScript is still available in TypeScript. So if I have a function that might return anything, I can type it as any and I can return a string or I can return the number 1. So it's pretty straightforward. So this is what it built. Basically, because I have it targeting older browsers, it automatically turned the string interpolation into concatenation for me. So I didn't have to change a thing on my side. You can see this just looks like plain JavaScript. It's just removed the type annotations. Those are just there for while I'm building the code. Same thing with the list and the push. Now this is this is the implementation of the enumeration. So all I had to do over here was just define the enumeration and tell it what the values were. And here I initialized it to 42. It went ahead and built an immediately invoked function expression for me and used this pattern that basically says, if this enumeration's been defined somewhere, use it. Otherwise, create a new object and then build on that object to create the enumeration type. So it saves me a lot of typing and a lot of work. And then I can run this. I go into my samples directory. And it's going to be amazing because it actually says x equals 2, hello world, false, 1, 2, 3, 4, whatever. Okay. So any questions on types before we jump to interfaces? Awesome. Check. All right, interfaces. Interfaces in TypeScript are interesting. Is anyone familiar with interfaces in Java? C#? Some higher level language that supports interfaces? So in most languages, an interface, it describes a contract, it describes what we expect, but an interface is a first-class type of its own, right? So even if I have two interfaces that look the same, I have an identifier, I have one too, in most higher-order languages, these are different types. They declare the same structure, but they're different types. In TypeScript, it's important to understand that an interface is defining a signature. So because this signature is exactly the same as that signature, these are essentially the same for TypeScript's purposes. So you're not creating a new type, you're just declaring an expectation, what you expect something to look like. So here I'm actually inlining, instead of using a named interface, I'm saying this type is something with an ID on it with a number. And of course I set it there, and if I try to give it a string, it's going to complain and tell me, no, we expected a number. And you can see down here, I can't give it foo because I didn't tell it we're expecting that property. And I can't assign the string because it's numeric. So all those expectations have been set. Now there's a lot of flexibility to how that works, but I want to show you this one. This is the exact same thing. So here I defined it inline. Here my object, I have one too, is basically just borrowing from this interface definition. These only happen at development time. These are not part of the code that's output. It's just keeping you sane and checking things for you while you're developing. Same thing here. I can't give it a foo because I didn't define it. And I can't give it a description because I didn't define that property. So just to show how this works, I've got my object as I have one too, and then my object too as I have an identifier. So I'm using different interfaces for these two types. This is expecting, and I have an identifier. And because I've declared that, I get what's called IntelliSense. So I can do object dot. And then over here you see I have an identifier ID number. So it tells me what to expect on that property. And so then I can say showing ID, etc. Here I'm passing it with my object, even though my object is I have one too because it fits the contract. Again, just reinforcing an interface is declaring the expectation of what's on that object. I'm actually just inlining an object here, but again, it meets the demands of the interface, so this is fine. If I wanted to do this and actually add a property that's not expected, it's going to complain. So a lot of power there. You can have optional types. So here I have an optional description. Description may or may not be there. And then I can mix and match. So I have an ID and maybe a description. Extends, I have an identifier and I have an optional description. So now I have a type that has ID and maybe description on it. So here I've got show description. I'm checking if it exists, and if it does, I'm logging it out. So this is perfectly fine. I have an ID and maybe a description because description's optional. If I were to take it off, it's still perfectly fine because description's optional. It's not going to complain. Yes?
If you have two different interfaces that have the same key with a different type as their value, will it tell you if you're extending them both?
Yes. And I'll show you some more advanced ways you can mix and match down the road. So this is just showing the description. So here's something interesting. So as we know in JavaScript, I can have a variable that I create as an object, and that can have properties on it, right? I might also assign a variable to a function. So if I say foo equals function blah blah blah, I can call foo, but yet I can still put properties on foo too. There's nothing stopping me from doing that. So TypeScript embraces that. This is an interface definition. It says this is going to implement an interface that takes two numbers and returns a number back. That's what this signature is. So here is an equation that implements this. It's a function that takes r and x, and it returns r times x times 1 minus x. Happens to be a bifurcation diagram, really cool chaos fractal. If you've ever seen it plotted, you can Google that too. But what I'm doing is going through bifurcation values. So here, setting a number, iterating through, calling it, and just showing the value. But then here I'm doing something interesting. I'm extending that function definition and saying that this object not only can be called directly as a function, but it also has a counter property on it. So this is just the flexibility. Just because you can do something doesn't mean you should, but we're showing you this flexibility. So now, after I define this, when I type this object out, so I can see if I do a dot, it's got function apply, and it's telling me how it can be called. It's going to give me number, or it's going to give me .counter and tell me it's a type of number. So it's handling all the different permutations of the way I can deal with this. And then I'm just calling it through and incrementing a count in this example. So if we look at that, I'm going to call this, and it's going to just give us an interesting list of numbers here. But if we look at the JavaScript associated with it, this is just plain JavaScript. Again, it just compiled it out. We're just showing an ID, we're just creating a function and calling it. So it compiles clear, clean JavaScript that you could have written yourself. Questions on interfaces? So now we get to classes. Classes is interesting because there are class support for modern browsers. So because there are a few of you who are familiar with Angular, let's say we had something that we called an ing Angular controller. Has a controller name, and then it has a save method that takes an array of parameters. And I'm stating here basically each parameter is a key and a value, key of type string, value of number. So it's a save method taking an array where everything in that array needs to have a key and a value on that. So now I'm using a class to implement it. Because I declared this private variable in the constructor, anything in the constructor in TypeScript that you declare as public or private becomes a property on that class that you can access. Because it's private, I can only access it within the class. Now this doesn't live in the JavaScript that's compiled. This is only keeping it safe for the developer. So if a developer comes in and tries to access something on the class, they're going to be locked out of it. The JavaScript it generates, you can access that property all day long. So it's not runtime safety, it's type safety development time. Because I'm implementing the interface, I can have something that's not on the interface. That's fine, my class can extend it. I use this very handy getter convention. So basically this is a read-only property that returns a string, and I'm just returning controller and whatever the seed is, like controller 1, 2, 3. The save method is basically implemented just the way the signature was, and all I'm doing is just iterating through it and writing out to the console. But because I've declared the definition, when I'm inside the console, first off I can see that it's a list of key value pairs, and so if I actually access something, I get this automatic intelligence that there's a key of a string or a value that's of a type number. So it gives me all of those tips inside the designer as I'm developing this code. So now I'm going to do the magic keystroke to reveal this code. And so debugging a controller, I can take in this controller type, and because that's there, I now can extend and see that I have these three properties to deal with. Not in the interface is fine, controller name and save. Notice I don't see that seed property because it was declared as private. And then I can save it and pass this in, and this is going to keep me honest here. If I try to pass something that isn't valid, for example, if I were to take the value and try to turn it into a string, it's going to complain and tell me that's not what it's that's not what it's expecting. So we can have very rich data structures that it still keeps us honest with. And then if we look at the generated code, what it did for legacy browsers is it created this immediately invoked function expression. So this is a function that's called immediately, and the reason why you would do that is because JavaScript has function scope, so anything declared inside of that function is not available outside. So now we have total control over how we create our objects. So in this case, for example, the controller is the constructor for this function, and it returns that. So that's exposed, and so I can do up an instance of it. Some of the other things that are inside it, though, unless I put it on this prototype so it's available, it's not going to be available outside of it, like the not in the interface is fine, because that's inside the function itself. So here's something interesting I want to show you, though. If I run this and tell it to compile to ECMAScript 6, which is what the modern browsers run, does anyone get to develop in ECMAScript 6, by the way, at your jobs? That's great to be able to work with the latest version. So what that did is, this is the JavaScript code now. Notice we have class, we have constructor, we have controller name. There's no type annotation, but get controller name. So it's aligned very much with the language. It looks almost identical. It was smart enough to compile straight to ECMAScript 6 that you're used to, but if you're dealing with an older browser, it created the immediately invoked function expression that we need to be able to run the older browsers. Let me just go ahead and run this, and then I'm going to expand it for you. And that's great because I actually didn't, no, I called debug controller, but I didn't save it. Saving is always a good step, and there it's gone through and done foo and bar, which are the values that I passed to it. So the other cool thing in TypeScript is you have this concept of modules, and modules a little bit overloaded because modules, think of it as a namespace. So it's a container for related properties and classes, and you control whether or not the outside has access to them. Now this does tie in, and I'm not getting into it today because it's intro to TypeScript, but if you're doing things like dynamic module loading and you have multiple modules that are included in, this ties into that concept as well and has some extra functionality around it. But basically, in this module, I've created an internal class. Now it's internal to the module, so anything inside this module can reference it, but nothing outside of the module is going to be able to. I'm exporting this class, so then that's available to the universe. So here inside the module, I'm creating the internal class, and that's perfectly fine. I'm also creating the my class, and that's perfectly fine. Outside of the module, I have to qualify it. So my module.myClass, and I'm calling that, but you'll notice if I try to access that internal class, it's not available because I didn't export it out. So again, when I save this, for the old version of JavaScript, it's going to implement these immediately invoked function statements. And what you'll see here is basically, it looks a little weird, but once you're used to the pattern, you can identify it pretty straightforward. If that module is already defined, it's going to use it. Otherwise, it's going to initialize it to an empty object. And then inside the function, it's adding things to it. So because it added my class to this variable that's returned at the end, that makes it available outside of the function. On the internal class, you'll notice the internal class is defined here, and it's returned inside the function, but it's not set to the myModule variable, so you can't see it outside of it. And that works with the legacy. And then with ECMAScript 6, it's going to compile to the more modern version of ECMAScript 6. There's no support in ES6 for module definitions. Those are still immediately invoked function expressions. And I just like saying that over and over again, which is why I brought that up. All right, let's move on. Any questions about classes, by the way?
I have one on modules.
Okay.
Yeah, use System.js. I like System.js. I wonder if TypeScript works well with it.
So I have used System.js, and TypeScript works fine with it. In fact, and it's been a while since I've worked on Angular projects, but as of when was it, Angular 2, and I know it's just Angular now, and it new versions released every other month. But initially they were using, before they went to Webpack, actually they were using System.js with Webpack on it, and it worked fine. And that's where I talked about, I don't have a slide for it because I'm trying to keep it intro level, but when I talk about deferred asynchronous module, TypeScript lets you use this convention that just says import whatever classes you want from a module, and that's what you do throughout your code. And then when you compile it, you tell it, I want to implement this with System.js or with Require or with AMD, and it will actually generate the code, Require parentheses or with the System.js and everything boilerplate to hook it up to that system, which is a great advantage. If you decided mid-project to swap it out and say, I'm going from System.js to Require, you could do that. You'd have to change your Webpack configuration, but you could do that as far as dynamic module living. So Lambda expressions are a way of solving what we talked about, like what is this, right? And the whole this-capades. But basically what I've done is I've set x to 42 outside of everything, and then I immediately start this Lambda function. So Lambda function has basically a signature. Does it have any parameters? So this one's empty, no parameters. And then it has this character. Does anyone know what that's called?
Function.
I like calling it the Gacinta, right? Because this goes into this. But I mean, I don't know if there's a official name or not. But so the Gacinta function here, inside of this we're doing this x equals 12. And then here I have a classical set of functions. This is the way we normally write functions in JavaScript. Iterations, index 0 to 10, increment x, console log this, set timeout, iterations, this x. So it's going 0 to 10, incrementing x, and then logging to the console, this is the value of x. Down here I have almost the exact same code, but I'm using the Gacinta, and I'm using a Lambda expression basically. So Lambda expression here, and a Lambda expression here. So same code, but with a Lambda. So let's take a look at, and then I'm calling the old school way, the new school way, and this is calling just the whole app itself. So let's take a look at what happens here. So what we end up seeing is the old one, as it's iterating through the loop, it's going 43, 44, 45 through 52, but then in the set timeout it's undefined. When we use the Lambda expression, it's going 13, 14 through 22, and then the set timeout is 22. So the reason why this happened, and then you'll see it in the code, is when you use Lambda expressions, it gives you hierarchical scope. So anything you declare outside of that expression is pulled into it, and it has a consistent value for this. This refers to the outer this. So in this case, this is a Lambda expression, so this x outside here gets pulled in. But this function doesn't know about that, because it's just a traditional function that's using this. So this now refers to this function, so it basically brought in this x that's outside, and then this x, and I know this is confusing, but that's what this is meant to clear up, is actually this function here. And this function never declared x, so there's no x for it to look at. When we come down to the Lambda expression though, behind the scenes, this captured this. This captured this. Underscore this is this. X was not part of underscore this, but that's implicit, right? Because it's outside of everything. So inside, the special this gets the 12. So inside the Lambda function, this is still referring to the same thing. And inside the set timeout, it's still referring to the same thing. So it inherits that scope all the way through. Does anyone know why the set timeout just said 22 the whole time? Anyone have a simple explanation? So basically the set timeout simply queued that call. So when you do set timeout 0, it queued up 10 calls, but it waits for the iteration to complete before it starts invoking those calls. So when x is 12, 13, 14, 15, all the way up to 22, and that was the last value of x. So then when it queued the calls, all the calls say is console log this x, so this x is 22, so they all hit 22. There's actually a way to get around that little gem, and I'm going to show you that in the next piece where we talk about scope. So scope is something that a lot of people struggle with in JavaScript because JavaScript is actually function scope. It's not block scope, it's not lexical scope, it's function scope. Scope changes inside a function. So when you have a for loop is not a new function, so anything you declare there is actually the outside scope of that for loop. So what happens here is I've got two Lambda expressions that are almost exactly identical. They do a set timeout and they log a variable. This one uses the traditional variable index number less than 10. This one uses let. So if anyone's not familiar with let says, get rid of the insanity. I want to use lexical scope. I want this variable to look like it just belongs to this for loop. So let says, let it be lexical scope. So what will happen when we run this is when we use the traditional JavaScript scope, it iterates through, goes 1 through 10, then those queued up functions are called, and they're all 10. When we use lexical scope, each set timeout gets its own copy because it's scoped to that for loop. And so it's captured in the set timeout and it gets the values of X you'd expect. Now here's something really interesting. When you go behind the scenes and you look at the scope, this is actually a pattern that a lot of JavaScript developers understand to avoid that capture where you just get the last value of the variable. So instead of calling the function directly, there's basically a factory that calls the function, and because you pass a variable into the factory, this captures the variable value. So it captures 0, 1, 2, 3, 4, 5. So this is using old JavaScript and using a pattern that developers use to enable that lexical scope. You do it very simply over here just by using let, and it generates the code. Now if we actually compile this to ECMAScript 2015/Harmony/ES6, then this is what we get. And it looks the exact same because ECMAScript 6 supports lexical scope. It understands the let keyword, so TypeScript automatically passed that through for me. All right, now you're looking at this file name saying complex. That was, weren't we already there? Why do we have to go to a new file? But there are even more advanced ways that you can manage types. For example, I can say a type is a number or a string. So this is fine and this is fine, but setting it to false is not fine because it can only be a number or a string. So a lot of flexibility. I can intersect. So I can say this name value is a key, so that's one type, and a value, so that's another type, and now I have a new type that has both key and value. So or up here and down here, and again, because I didn't define foo, it gives me an error. But you can get yourself in trouble, right? With great power comes great responsibility. So if I say that my type is both a number and a string, I can't assign it anything. Fortunately, I figured that out before I compile code and ship it. So, because we know if it compiles, it's ready to ship, right? We're good? DevOps for the 21st century. So this is a custom type, name value pair. Really, custom types are meant to be ways of, they're very similar to interfaces. They actually restrict you a little bit more. You're saying I'm only dealing with this type, so you can't extend them. That's really the only difference. You're still defining a signature, but I'm going to show you something at the very end, advanced, that you can do that's pretty interesting with those. So just file that away. I need some sort of hook to keep you engaged and interested for the next 15 minutes, so that's it. I'm sticking with it. Anyone here familiar with the spread operator? Cool, a lot of people. So spread operator is awesome. Basically allows you to do things like merge objects, clone objects, deal with an array, and basically you use a ... That's the spread operator. And I can say that here's an object and ... another object, so inherit all these properties, and it does it for me. So if I have an object foo bar that is x of 0 and I just assign it, we know that's not really a copy, so if I change the source x to 1 and I log the copy, it's going to be 1, 2 because they're just pointing to the same object. If I use the spread operator, dun, 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 then it's actually a real copy, and what we would expect is when we change the source, the real copy is still what we copied it as. I'm going to show you that in a second. We can do the same thing with arrays. So here I'm just assigning it, so what happens to the source is going to happen to the target. But here, because I'm using the spread operator, it's actually making a copy for me. And then I'm going to go into the manipulator stuff in a second. So let's just run this real quick. And copies 0, copies 1, real copies 1, change it to 5, still 1. So the spread operator, and basically behind the scenes, again for older JavaScript, TypeScript did all the work for me of actually emitting a method. Am I going to make myself dishonest? Yeah, so using object assign basically to make that copy. So it's using that convention. Whereas if I compile it to ES6, I'm not going to do it just for the sake of time. Then it's just going to use the spread operator because it's supported out of the box. So this is really just my attempt to warp your mind and blow it with the complexity of what you can do with TypeScript. So this is a manipulator actually, let's go into the TypeScript. So I have a manipulator, and that's an interface for something that manipulates a string. It takes a string and returns a string. So that's one building block. Then I have an interface of something that can manipulate, and that takes a key and an input string and returns a string. So now we're implying that we have different types of manipulations. That's what this interface implies. I can have a cache of manipulators that is indexed by the key and returns a single manipulator instance. So I'm a manipulator, here's a cache, and give me the key, I'll return the manipulator. So I can take a manipulator manager that extends iManipulate and allows me to register a manipulator. Everyone still with me? So we're going to pass in and say, hey, here's a manipulator that echoes text back. I'm going to register it with this name. So now I have this class that's manipulator manager. It has a cache that's a manipulator cache. But what's cool about this cache is because the way I defined it up here, when I index something in the cache, it actually gives me the signature of the method that it's going to call. Even though what I'm doing is actually assigning properties to an object. It's not even an array. So it's pretty cool that way. Here's my register manipulator. Basically, if we have the key, I'm going to return false and say, no, no, no. You already registered that. Otherwise, I'm going to set it onto the object with that key. Then if you call manipulate, I'm going to look. And if I have a manipulator with that name, I'm going to call it with your input. Otherwise, I have something called the default echo manipulator, which, believe it or not, echoes the string back. So here I'm creating a new manipulator manager. I'm registering a manipulator that reverses a string. So that's input split reverse join, right? We do that all the time. And then console log, and I think I still have my old run here. You can see that when I called it with something that doesn't exist, it just echoed the string back. Otherwise, it reversed it. And to set Denosis, YMC, anyway, so that's what we get back. In JavaScript, you're just going to see a class that sets some properties, but what happens is if you implemented this directly in JavaScript and you did a dot property on an object for a property that you haven't yet defined, you're going to get no IntelliSense and no feedback on what you're actually returning. In this case, we know it's a function that takes a string and returns a string. So generics, who here is familiar with generics? Who's not familiar with generics? This is good because we had about half and then we had about half, so most of the people are awake. So here's what generics do. Generics say I have a strategy for doing something, but instead of just dealing with it as a generic kind of object thing that I don't know what it is, I'm going to let you create a strategy that says when a type comes in, that type's going to be carried throughout the plane. And the canonical example of this is if I have a dictionary of something, I might have an array of numbers or I might have an array of strings. And I want to give you a find function that says you're going to find something in the array. Now without generics, you're just taking in a generic array. It's kind of ironic, I know, but it's a generic array. You do the find function, you're getting back a generic object. You have no idea what that is. With generics, if you type it correctly, You're saying when I pass in an array of numbers, what I get back is a number. When I pass in an array of strings, what I get back is a string. It's a lot easier when you actually see it in action. So let me just walk through that. So I has ID is my interface that has an ID. I'm very creative with my naming conventions. My class implements that, adds description. So here's the rub. Non-generic echo takes in an item as I has ID and returns the item back. And this is just a contrived example. So the interesting thing about it is I can have a bunch of different classes with a bunch of different properties. As long as they have an ID, I can pass it to this class and it'll return it back. Here's the generic one. The generic one says my strategy is T. T has to extend I has ID. So give me any type, but the type has to have an ID on it. And then you're going to pass me an item of that type, and I'm going to return that type back. So it's the same code inside, but now it's using generics. So here's what happens. I'm creating an instance of the class. When I use the non-generic version, what I get back is an I has ID. Because that's the way I defined it, right? So I know that this class has a description on it. That's exactly what I pass in and what it's passing back. But because of the signature of that method call, it doesn't know that because it's just returning an I has ID type. With the generic, on the other hand, the generic sees that the type going in is my class, so it gets passed out is a type of my class, and now I can work with the description. So that's the power of generics compared to non-generic. So taking that further, I can have a predicate, which is just a true or false. So give me a type and perform some condition that returns true or false. It's just a test, right? So bring in a type, return true or false. So I have a list of key value pairs, and then I have this strategy to find the first item in a list. So it's going to take a list of a type and a predicate. Remember, this predicate is a test for that type. So give me something that tests for that type, and the first one that passes the test, I'm going to return it back. So what happens down here is I'm passing in my list, but here's the interesting thing, is because I'm passing in the type, it's now going to let me know that what I have to bring back is going to be not this, right? I'm trying to force it to true. It's going to tell me, no, you need something of a predicate of a key value pair because that's what you passed in. So it understands that type strategy. So I have to take the item, which is a key value pair. In my code, it now knows it's a key value pair, so it gives me IntelliSense. I know I can check for the key or the value. And so in this case, we're checking for key, and then it's going to return that result. And because that result's returned back as that type, it also gives me IntelliSense. So it lets me carry those types throughout the entire system. Make sense? Come back to it a little later. All right. Decorators. If you've worked with Angular, you've seen decorators. I'm not going to spend too much time on this because I want to show you a quick project and then get you out of here at a decent hour so we can enjoy the rain and gloom that's outside. But basically, aspect-oriented programming, and I talk a lot about this. One of the reasons why I think Angular is such a popular framework, Vue, frameworks like that, is because of declarative versus imperative. In a nutshell, imperative says how to do something, declarative says what you want to get done. And so when you do a data binding in Angular and you say this binds to this, you're saying what I want is I want this item to bind to this item. Angular takes care of the how. It does all the code behind it. And so there's less potential for mistakes because you don't have 5 different developers implementing that 5 different ways. They're declaring what they want, you have one how, and it's good to go. This is similar. TypeScript allows you to declare these things called decorators. And what they are is basically aspects or cross-cutting concerns that you can put on a class. And so what I've got here is a decorator class. And it's just a regular JavaScript function. And then TypeScript's going to wire up all the code to make it magical. And I'll show you what that magic looks like. So here I'm taking a constructor. I'm using some JavaScript to basically, if you do a function to a string, you get the full text of the function. So I'm parsing out what the function name is. And I'm returning that. That's what this little function does. And then I'm just logging that you constructed the name of that constructor and the date. So that's it. This method takes a constructor and it says you constructed blah, blah, blah at this date and time. So what I've got here is forget about log for a second, we'll come back. I've got a person class that gets a first name and a last name, and then this incredibly useful method that you pass in a prefix and it echoes back the name with the prefix. So if I pass in Mr., then it'll come back Mr., Mrs., whatever the title is, Senor. And then, so person new Jeremy Likness. I also took the liberty of defining the class as special person. I didn't even inherit. And of course, that's going to be my wife, Doreen. And it's going to echo that back. So if we run that, what we get, hello, Mr. Jeremy Likness. Hello, Mrs. Doreen Likness. Pretty straightforward. So now what I'm going to do is take this reusable behavior, this aspect of CTOR, and I'm just going to use an @ sign and tag the person class. I'm also going to go ahead and tag the special person class with it. So this is how I reuse it. I define it once, CTOR. I declare it. Now, without changing anything else, when I run this, I get constructed. That might be a little useful, right? To have a behavior you can reuse and apply. So what we do up here is we're actually now doing a log method. And so this is a method decorator. So now I'm saying I can basically, and I'm not going to get into all the nuances, but I get this thing called a descriptor that gives me information about the method I'm attaching to. TypeScript provides that for me. I'm creating a function that takes any list of arguments, making use of the spread operator. Then I'm saying, here's the arguments you passed into the method. I'm getting the result, saying here's the result, and then I'm returning that result. So I'm basically intercepting the method, getting some metadata about it, showing it, and then returning it. So what happens now is if I decorate person with log, and I run the same code, log save, and we do not need to know the get version. That's quite all right. And I run this, then boom, for my name, the method args are, the return value is. So it went ahead and intercepted and used that method interceptor and extended it for me. This is how Angular does @component, @injectable, and does all these behaviors. You can build them yourself. And then I have this log to source, which is actually a decorator that takes a parameter. So here I'm going to do log to source, and I've created a log with time, and I'm going to also do log to source with console.info. So I'm passing in the method that it's going to use for the logging. We'll save that, and we'll run that. And now you can see that it called both of these, method args, and then method args with the time. Then it got the return value, and then it returned this. So this is a way to create some sort of behavior that you want to reuse throughout your code base, and just by tagging it with the @ it goes there. And then behind the scenes, TypeScript creates all these complex functions that actually get the original method, build up the descriptor function, transform the description, and does all that for you. In a future version of JavaScript, decorators will most likely be a native feature. It hasn't been finalized yet. It's experimental. Last thing I want to show you before we do a really quick project, and I promise you it will be quick, is some of the advanced features. I'm not going to get too bogged down in this because this is intro, but I just want to show you some of what's possible. And this is more like you've been exposed to it now, and so you can go back and look at it and dig into it. So I can create a type like awesomeness that is really a string type, but has a set of allowable values, low, medium, and high. So as an advocate, my name, my Twitter, my level of awesome is of type awesomeness. And then I've got this, don't worry about this, I'll come back to this. So I'm creating advocate, Jeremy Likness, there's my Twitter, and I must think highly of myself. Let's just do medium so I can be a little humble during the talk. So I have a good friend who's on my team as well that you may have heard of, John Papa. And I think some people who know him would agree his level of awesome is unmeasurable. He's a pretty awesome dude in the Angular community. If I try to do this though, it's going to complain because I've restricted the allowable types to these. So this is still a string, it acts as a string, it's not enumerable or anything, but I've actually constrained the type. So I would actually have to come here and make this unmeasurable. If I could actually type, I just need to shift my fingers to the left. And now this is allowed. You see the squigglies went away. So that's pretty cool. This key of actually says that this property has to be one of the keys defined for a class or an interface. So in other words, if I have this get property that's a generic, find any property on an object and returns it, and I say get property Twitter, that's fine. But if I say get property LinkedIn, it's going to complain because I didn't define that on the interface. Think of how that can protect you in some of the utilities and types of code you do. We've got a constructor implementation. I'm not going to go into that. The only other thing I want to talk about is type guards. I'm going to talk about these really quick. Type guards are kind of conditional IntelliSense. So this type guard is for a number. And it knows that because I've declared this as input as number and I'm looking at the type. So what happens is test is declared as any. So it can be anything. It could be a number, it could be a string or whatever. So if I tried to do something with test, say I'm hitting dots, notice that nothing expands because it has no clue what the methods might be because it could be anything. But if I test it as is number, and because this method has this type guard on it, TypeScript now knows the only possible way this code can execute is if the type of what I passed in is a number. So now when I do test dot, I get all of the number methods and properties. So it's a way that I get conditional IntelliSense in my code based on, and then this is an implicit type guard. I'm just checking directly for secret, and then it exposes the method. This is allowed because it's of type any, but you don't get IntelliSense unless you come in here because now it knows it's a string. So the last thing that I wanted to show you is really quickly, I promised to build a project really quick. I keep saying quick, and saying it doesn't necessarily make it so let's just do this. We're going to go into documents, we're going to go into temp, we're going to make dir intro to JS. It was actually TypeScript, but that's okay. So what I'm doing is initializing a Node project, and the only reason I'm using Node is to get the TypeScript compiler. I'm not making a Node application, I'm just taking advantage of the compiler. I'm going to install TypeScript and just tell it to save it as a developer tool. So again, these are just standard Node commands. Thank you, Internet, for doing that quickly. And then I'm going to run a command from what I just installed. It's TypeScript compiler, and tell it to initialize a tsconfig. So you have total control of how it's compiled, of what it uses, system.js, if it goes to old version, JavaScript, new. So this just creates a file for that. So if I do code dot here in this directory, you're going to see I have this big configuration file that's commented out. We could do tons of things with it. I'm just going to create a script called build that runs the TypeScript compiler. That's it, simple script. And then let's go ahead and create an index.html. And I'm going to call this, we've got a head, my first TypeScript web app, body, h1, this is cool, p, type stuff, it's pretty direct, placeholder equals type stuff, id equals input text. Alright, so an input field, and then h3, hopefully something happens here. So what I'm about to show you will actually eliminate the need to have Angular, Vue, or React in any of your projects. It's going to be incredible. So we're going to include main.js, but Jeremy, there is no main.js, right? So if we were to actually look at this right now and open it up, it's going to be extremely boring. We type stuff and absolutely nothing happens. Never fear. Come back. Now I'm going to add a new file, call it main.ts for TypeScript. I'm going to create a constant function, call it go. And here's what I'm going to do. I'm going to do an HTML input element. So constant input type HTML input element equals, and this is how we cast a type basically, because I'm going to use a method that can return multiple types, and so I'm forcing it into a single one, and that's document get element by ID input text, I think is what I called it. I should check that really quick. Did you notice how I had that auto completion though? I did it pretty quickly, but if I did document, I get everything that I need there. So I'm going to show you a little bit more of that in a second, but first we want to do h3, which is an HTML heading element. And this time we're going to do HTML heading element, document, get elements by, and again, I don't have to memorize these, no Google required for this demo. Get elements by tag name, h3, and we're going to grab the first one. So now what I want to do is on the input, on key up, and see I get that auto completion automatically. Actually, yeah, on key up, and I don't care what the value is. What I'm going to do inside here is say text equals input dot, and I get the full list of possible values, so I know that value is how I get what's in the input field. Then on the h3, I'm going to do inner text equals text, and then I'm going to do a set timeout go 0. So this all happens after it initializes. So what I need to do is generate my JavaScript. So we'll pop into here, go into our terminal, and npm run script build. Dun, dun, dun. No, just kidding. And then we're going to refresh this. This no longer requires Angular. Thank you.
Wow.